Math 2, Unit 5, Worksheet 2, Properties of Parallelograms. Okay, as you know, this unit's going to move very quickly, and it is basically focusing on quadrilaterals, four-sided polygons. And we're going to go over those quadrilaterals in a sequence. And the first one is parallelograms. And then we will study a more specific parallelogram tomorrow. Today is just a basic parallelogram, and it has some properties, and we want to write these properties down as we go. So, let's read the instructions. The given figures are all parallelograms. Solve for the variables in each diagram, then state the property of the parallelogram that allows you to solve for the variables. Okay, so in this case, what we can say is x plus 51 equals 180. Okay? We subtract 51 from both sides and we get x equals 129. So x equals 129 degrees. All right, so does anybody have an idea what the property is that we want to state? Okay, so let's think. This is called a parallelogram, isn't it? So what that means is opposite sides are parallel. So we know this side is parallel to this side. We can show it with an arrowhead. And we also know these two sides are parallel. And we can show that with two arrowheads. Okay? So in a parallelogram, opposite sides are parallel. So let's think of these two lines right here as parallel lines cut by a transversal. So now we should know that same side interior angles are congruent, aren't they? All right. So in a parallelogram, let's write that. Consecutive angles are congruent. Or we could even say adjacent angles. No, I don't think we'll say adjacent angles because sometimes that means adjacent angles usually means like two angles like this typically means adjacent, so they share a side, right? So consecutive means one after another, right? If we talked about consecutive classrooms, I'm in S14, right next door S13, consecutive, right? Next to. It means a little bit different than adjacent. Adjacent means they share a wall. So I am adjacent to S13. But if we think about number or order, we're consecutive. Okay, start down there at the hall, it's S11, S12, S13, S14. Consecutive, one after another. Does that make sense? So that means these two angles are supplementary. Oh, shoot. Was thinking ahead. They're not congruent, they're supplementary. I'm sorry. Sorry about that. That's a bad way to start a video. I worked out supplementary and I said congruent. Consecutive angles are supplementary because of same side interior angles. So these two guys are supplementary, but remember, these two guys are supplementary. So we know this is 129 degrees. And we also know this guy is 51 degrees because consecutive angles are supplementary. So if that's 129, if this is 51, that's got to be 129. If this is 129, this has got to be 51. And if this is 51, that's got to be 129. In a parallelogram, consecutive angles are congruent. So far, so good? All right, let's go to the next guy. Okay, number 2. So DG is 2x plus 2. DE is 3x plus 1. EF is 3x minus 3. And GF is 2x plus 6. and we want to solve for x. So I got a couple of different options on this one. Has everybody got those written in?
Yeah.
Okay. What I'm going to say is 3x plus 1 equals 2x plus 6. I'm going to subtract 2x from both sides, and I'm going to subtract 1 from both sides. Here the 2x cancels, here the 1's cancel. 3x minus 2x is x. 6 minus 1 is 5. So I know x is 5. And by the way, I could also do 3x minus 3 equals 2x plus 2. Again, subtract 2x from both sides. This time add 3 to both sides. Here the 2x's cancel, here the 3's cancel. And we end up with 3x minus 2x is x, and 2 plus 3 is 5. And you can see that we end up with x equals 5 both times. So what does that tell us?
All the sides are equal.
What's that?
All the sides are equal.
No, not all the sides are equal. Well, you know, that is actually a really bad example. We should have done it differently. It tells us something different. You are correct. In this case, all sides are equal, but that's not what it's supposed to tell us. It's supposed to tell us that opposite sides are equal. Okay? So again, let's write this property down in a parallelogram. Opposite sides, and this time I am correct, are congruent. In a parallelogram, opposite sides are congruent. So if you think about it, if I have two lines that are parallel, and I have, lack of better stuff, two other lines that are parallel. Okay, the distance from each end has got to be the same if they're parallel. If they're not parallel, well then this guy has got to be longer because it takes him longer to get there, right? But if they're parallel, okay, then obviously the distance from here to here has to be congruent. And the same from here. I could actually take this side, if I could move him, because he's moving along parallel lines, I could slide him right up and he would be the same distance. I could take this guy and slide him right over and he would match up. So in a parallelogram, opposite sides are congruent. Make sense? Questions? Okay. Let's go on here. Number 3. What I can do to solve here is I can say 3a minus 5 equals 40. I can add 5 to both sides. I get 3a equals 45. Divide both sides by 3, and I get a equals 15. All right. So actually, I already talked about this one up in number 1. Didn't really state it, but what do you think the property is here? Let's start it off in a parallelogram. What do you guys think? Opposite angles are what? Congruent. I set these two guys equal to each other. You can write out congruent or use the symbol. And here's a great example why. We already proved why consecutive angles are supplementary, right? Well, if these two are supplementary, and these two are supplementary, and these two, obviously then opposite angles have to be congruent, don't they? Okay? Questions on number, where are we at? 3. Questions on 3. All right, let's move on. Number 4. All of a sudden now we have, anybody know what these are called? Nope. Diagonals. Okay. A diagonal runs from one vertice to a non-adjacent, a non-consecutive vertice. I keep saying adjacent. Non-consecutive vertice. Okay, so A to D would be a side, but A to C is a diagonal. D to B is a diagonal. Okay? All right. So we're finding X and Y now. We've already done these two guys. Well, we've actually already worked this out. Am I missing the property up here? DG, DE, EF. Well, I don't know. I'll have to take a look. I don't know what I'm missing here, but in this case, it is simply 3x minus 5 equals 2x plus 2, correct? We subtract 2x from both sides, we get x minus 5 equals 2. We add 5 to both sides, we get x equals 7. And that's because in a parallelogram, opposite sides are congruent, right? And 2y minus 6 equals y plus 3. Subtract y from both sides, we end up with 1y over here. Add 6 to both sides, and we get y equals 9. And that would be the same property we just wrote down. No, they've got it here. I have to be honest with you guys, I don't know if I'm missing one. This would be for a rhombus, which we're not doing today. So tomorrow, I believe we study, or the next day we study a rhombus, which is a parallelogram with 4 congruent sides. That wasn't the point today. So this is basically the same as number 2. In a parallelogram, opposite sides are congruent. Okay? So you can rewrite it if you want. I think they made a mistake, but I'll double check. We found a few mistakes in our new worksheets so far. So, all right. So number 5 is the next property. And what I'm going to do is I'm going to solve for, oh, this is a tricky one. They're giving, okay, so here's what I'm going to do first. I'm going to say 2x plus 5 equals 11. 2x plus 5 equals 11. So I'll subtract 5 from both sides, and I get 2x equals 6. Divide both sides by 2, and I get x equals 3. Okay? Because in a parallelogram, diagonals bisect each other. Okay? So in a parallelogram, when you draw the diagonals in, these diagonals bisect each other. So what we can say is that 2x plus 5 is congruent, well, I should say 2x plus 5 equals 11. And now obviously the diagonals aren't congruent. This one is shorter than this one because it's got further to go. But now we can solve for y by going y plus 4 equals 2 times 3 plus 4, which means y plus 4 equals 6 plus 4, which means y plus 4 equals 10, which means y equals 6. Okay, does everybody understand how I came up with that last? All right, I'm gonna be honest with you, I'm not gonna prove this to you. We could, using congruent triangles, I could prove that this triangle is congruent to this triangle. Okay? And then we could say that obviously A, if I called this E, I could show you that AE is congruent to CE if we went through the process of proving two triangles are congruent. And then corresponding parts of congruent triangles are congruent, right? But we're not going to do that. Let's turn the page. All right. So, can you prove the quadrilateral is a parallelogram based on the given information? Explain. So, what you basically need is, the one thing that's a little bit different is when we talk about the sides. Like, I'm going to do number 9 with you. All right. So, in a parallelogram, if you can take two of those properties and prove them to be true, then it is a parallelogram. So let me go back actually for a second. So it's not good enough to say that one set of opposite sides are parallel. You have to say that both sets of opposite sides are parallel. So you've actually stated two things. Two sets of opposite sides are parallel. Or you could say that saying that one set of opposite angles are congruent is not enough, because I could make a set of opposite sides congruent and the other two not be congruent. So you have to be able to say that both sets of opposite angles are congruent. You have to state two of the properties basically. So let's take a look at this. Oops, over here. I guess we'll do a few of these because this is a pretty big worksheet and I don't want to make you guys do all of them. So, oh no, that's worksheet 3. Oh yeah, we're good. All right, so let's take a look at number 9. Can I state that number 9 is a parallelogram? Yes. It has one set of, and I'm going to write parallel. This is the way we can abbreviate parallel sides. And one set of opposite sides that are congruent. Okay, so we know that these two sides are parallel, and we know that these two sides are congruent. All right? We could do the same if we could say that these two sides were parallel and congruent, it would work. Two of the properties have to be present in order for it to be a parallelogram. Okay? Like right down here, look at that. We have a set of parallel sides that are also congruent. So that is a parallelogram. You guys think you could finish these? Yep. Okay, so I'll leave 6 through 11 for you to finish. Any questions on any of those you'd like me to go over? No? Okay, let's go on to 12 through 15. Okay, so now we're basically taking the properties and we are using the properties that we learned, hopefully, to solve for x and y. Are any of those you would like me to do? Come on, I'm willing to do one of them with you.
14.
14, okay? All right, so this is the property where here they're saying for what value of x and y must each figure be a parallelogram. So what we're saying is if this is a parallelogram, properties have to apply. And we know in a parallelogram that diagonals bisect each other. So we know if this is a parallelogram, this diagonal half and this diagonal half have to be congruent. And we know that this line segment and this line segment have to be congruent. If this thing is going to be a parallelogram, this has to be true. So therefore, I can say that, got to be careful about what you do here. I'm going to solve for these two guys first. 5x minus 4 equals 2x plus 14. So I'm going to subtract 2x from both sides, which will give me 3x minus 4 equals 14. I'm going to add 4 to both sides, which will give me 3x equals 18. And then I'll divide both sides by 3 and I get x equals 6. Okay, now that I know that x equals 6, now I can solve for the other two. See, I couldn't do this one first because I'd have a y and an x in the same equation. So now I can say, though, 2y equals x, which means 2y equals 6. Divide both sides by 2 and I get y equals 3. All right, and I use the fact that in a parallelogram, diagonals bisect each other. So good? All right, and then number 16, a classmate draws a parallelogram for which one side is twice as long as the other. If one side is 26 units, what are all the possibilities of the perimeter? Okay. So it says a classmate draws a parallelogram. So let's just draw a parallelogram. I should actually leave this for you guys to figure out because this is a thinking man's problem. This is what I love about geometry. It makes you think a little bit. So we know that one side is 26 units. So I'm just going to call this guy 26, which means this guy is 26, correct? Okay, so a classmate draws a parallelogram for which one side is twice as long as the other. Did it say which side? No. If one side is 26, it means two of the sides are 26. What are all the possible lengths of the perimeter? Remember, perimeter's all the way around. I'm going to leave that for you guys to mess around with for a little bit. And the proof, which I'm going to leave for you guys. Yes?
Now, can you go over number 12?
Yep, number 12. Okay. Okay. Well, if you were thinking, well, opposite angles are congruent, if you look, you really can't solve for each of those, could you? You could say 2y equals x, but you can't solve that. You could say 5x minus 180 equals 4y, but you can't solve that, can you? So that property is not going to work for us. But what's another property that would work for us? What do we know about consecutive angles in a parallelogram? They equal 180. So it looks to me like 6y should equal 180. Divide both sides by 6, we get y equals 30. Okay, and now if y equals 30, this angle is 60, right? Which means x equals, boom, easy peasy. All right, so I'm going to give you guys the rest of the period to finish up this worksheet. I apologize, I'm not done grading your test, as most of you probably already know. I am here till 9 o'clock tonight, so I will be finishing your tests today after school, and I will hopefully have all your grades in by 9. Your grades should be completely updated. We'll go over the tests. If you're dying to tomorrow, but I'd rather wait till block day when we have a little more time. Okay? So we'll see. Any questions? Everybody know what they're doing? Ready, break.